Hey YouTube, what's up? It's Slink. I am the developer of Slinksoft, and I've wanted to make this video for quite some time. The first reason is I want to teach beginner developers out there the concepts and fundamentals of object-oriented programming. And two, I want to reflect back on myself in the future, see how much I've grown, or if I have to brush up on the fundamentals of object-oriented programming myself. For these sets of tutorials, I will be using the Java programming language. This is the language I used when I was taking on my academic studies, and I still think up to this point in my life it's one of the better languages to learn the fundamentals of object-oriented programming. We will also be using the NetBeans IDE for these tutorials. Now, normally if I'm developing Java, I will not use NetBeans. I would either use IntelliJ or Eclipse, but just to kind of teach you guys the fundamentals of object-oriented programming, it's fine to use NetBeans in this case. So the topics we will be going over is primitives versus references or object references, encapsulation, polymorphism and interfaces, and abstraction or abstract classes and superclasses, and inheritance. These are the basic fundamentals of object-oriented programming. They're very important when it comes to OOP, and I'm going to walk you guys through each of those topics. Now, before we get started, if there's anything I explain improperly or I need to expand upon my explanation or make things a bit more clear, please leave a comment down below. I appreciate feedback from all sorts of developers. I take pride and passion in learning from you guys, learning from other developers. So I appreciate any feedback I receive, and I will take that feedback and make a future video addressing it. So that being said, let's get started, and I hope you guys enjoy these set of tutorials. So, without further ado, let's start off with primitives versus object references. So let's start off with primitives versus object references. So I wrote some primitive data types here to save us some time. So if you've taken your introductory programming class, I can't pronounce my words today, in your college or university, or if you're learning programming from various sources online, you'll know these common primitive data types, such as a 32-bit integer, a double, which is a 64-bit floating point decimal number. The float is a 32-bit representation of that, but unfortunately with Java's compiler, it's kind of weird if you actually put a valid value in this, so it throws a incompatible type exception. So this is just one way to assign a float its actual data. Not the best way. It's one way. Calls the float object reference value of and converts it from string to float. You have Boolean, which is a true and false value. Character, which holds a specific single character's value, such as capital A, which is 65 in the ACII table. '65 right here. You have a short, and a short is a 16-bit integer, along with this is a 64-bit integer, and the length of that is way bigger than a 32-bit integer. I'll show you right here. And in fact, if you try to put assign anything other than a little over 2 billion, which is a 32-bit signed integer's max value, it's going to have an error, but you can represent the max value with the long object reference, and it's really big number. And you have a byte, which is a 8-bit integer, and its max value is like 127 negative 128, I think is the minimum. Yeah. So these are your primitive data types, basic data types where you put some data into them. Now let's discuss non-primitive data types or object references. Now a string, when you're starting out programming in your introductory programming classes or learning online, you'll come across a string data type, which may look like a primitive data type at first, but it's not. Why? A string is a collection of characters. Again, a string is a collection of characters. So within that string, not just in the Java's collection, but even .NET and other languages, you'll see if I put s, which is the variable name for our string, there's many different methods or functions we can use to pass in some data and manipulate data within our program with our string, such as s.substring, and we'll put the index of 2, and that's just going to return LLO exclamation point, just like this. So this is not a primitive data type, it's a non-primitive data type or an object reference. An object reference is a class that you can instigate, and within that class is additional or more complex functionality that you can use and call upon to manipulate data and additional functionality within your program, such as long.maxValue, we're just getting the constant of the max value of long, but within this long class is many different methods we can use to pass in some data and return some other data, manipulate some data. Bit count, get long, value of, sum of two longs, and much more. So that is the difference. Now, another common mistake, and these could be interview questions actually, is arrays. Int r is equal to new int 32-bit signed integer array of 5. Is this a primitive data type, or is this a object reference or a non-primitive? You may think it looks like just regular old int. Well, this is a primitive data type. In fact, it is not. Arrays are non-primitive. They are object references. So for example, I can go ahead and write a for loop for int I is equal to 0, I is less than r dot. Now there's not many in an array, but there's functionality, methods that we can use within this array or call upon this array to do something, such as get the length, do a toString, which is not really useful. All this does is simply returns the memory address at the starting point of the array. Clone, which points this array to another array. That doesn't actually really clone an array properly. You can look that up for further reference, but all that does is points that array to another array. So, but all this functionality, such as length, and length is the most common use is to get the length of the array. I++, for example, if you're actually properly copying one array from another, or you're just going to output every element of the array on their own individual line, you do r_i. Mess that up. That'll never run. And as you can see, we have these 5 zeros. They're 5 zeros because we haven't really, that's the default value. We haven't set any of those arrays values. So, primitive this is a primitive, this is a primitive, this is a primitive, this is a primitive, this is a primitive. You get the point. This is a non-primitive, which is an object reference. Same thing with the array. So, what about creating our own object references, creating our own classes? Well, we have a person class here, basic person class. We go over the private string name in the encapsulation part, which is next after this. And in this person class, we have some mutators and successors, or getters and setters, which is pretty much we can use this method to set the actual name of our instance variable name. by passing in a name in when we call it from the person instance. Actually get the name, return the actual string, and a toString method. So we can installate this class person some guy is equal to new person, and we'll call that person, or we'll pass in a string parameter which will set the instance variable within that class, that instance of person, which is some guy, and set his name to Dan. Hold up. Oh, okay, we don't have a constructor. Sorry. Let me add the constructor. Actually, we don't have to do that. Let's not do that. I thought I had a constructor there. So we don't want to pass anything through. But now we can do some guy, which is our person instance. Do some guy dot set the name, and we'll set his name to Dan, and then we'll do an s out for some guy. Notice how I'm using some guy, which is my person instance, and calling these different methods to go ahead and return data, manipulate or set data, just like that. So that is an object reference. A person is our object reference. So over here, object reference. And it's very intuitive to see the difference between a primitive and a non-primitive, or an object reference. A primitive is your basic data types that you can store some value in them, such as a 32-bit integer, a car, a boolean, true and false value, etc., etc. And of course, you have your other common data types that are non-primitive, such as a string, which is a collection of characters, or an array of some data type. Now you can also have arrays of actual object references as well, such as I can have an array of person as well. Oops, I actually did something off camera. I had a constructor. Let me get rid of this. I was experimenting real quick. But such as this, an array of actual object references. Now you could, it would be better to use an array list for something like this, because then actually it might be the same thing. But then you use a for loop to actually create those actual new instances of those people. Especially if as a constructor, you have to go ahead and actually construct or actually initialize those instances of object references in your array. But this is still an object reference. So again, these are your basic data types. You put some value into them, and your object references or non-primitive data types are classes in your program or objects that you can instate, and within those instances of your objects, you can call upon many different methods that are defined and implemented to pass on some data and return some data, or manipulate some data and other functionality within your program. And that is the big difference between primitive and an object reference. So we're going to go over encapsulation next, and yeah. So we're going to go over encapsulation, which is very, very easy. What is encapsulation? So encapsulation is pretty much defined as wrapping data under a single unit. It's also another simpler way of defining it is preventing data from being accessed by other classes or other codes or other code that it wasn't instated in. What do I mean by that? Well, in the primitives versus references section, we went over this person class that I created, and it has a string variable called name, and it's public. Its accessor is public, just like these methods are all public. Now, the constructor is always public. But what happens if I change this to private? Now you're going to see I get an error here which is name has private access in person. Therefore, when I try to run the code, we're going to have a compiler error. We can't access that data in person called name. So this is pretty much encapsulation going into play. We can't directly access this data within this other class that we have instated in our main. So how do we access data that's being protected in another class? Well, again, in your introductory programming classes, you should have learned something called getters and setters. Another name for it are accessors and mutators. And these are public methods that will allow you to set and get these data types, these protected data pieces of data within the class. So we're going to do public void set name, and we're going to have an input parameter such as string name, and we're going to do this dot name. Now this dot name is going to get the instance variable up here, and if we just do equals name, name is going to get the actual parameter value. And now we're going to do a getter, which is public string, because that's a return type. It's not a void. We're not setting something. We're actually returning some data. Get name, and also this is bad practice. Should always be lowercase at first, as you can see, and then get name. And there's no input, and we're just going to return name. And for the sake of this, let's just we don't need a constructor in this case if we're just going to get rid of this and not do anything. So we'll just go ahead and get rid of the constructor itself. This takes in nothing anymore, as we can see. But of course, we can't access name directly. We can't set it. We can't access it. We can't set it or get its value, its data directly, that is. So this is where accessors and mutators and getters and setters come into play. So now we can do some guy dot set name. We'll put it to Dan, and in our sout, we can do some guy dot get name. If I can only spell it right. As you can see, we have set the name with our mutator or setter, and retrieve the name with our accessor or getter. This is encapsulation. It's data being protected under a class with private access that other classes cannot access or modify or assign data to it directly, unless that class. Not unless it. The only way to retrieve or get the value from that data, or actually assign it new data or new value, is using accessors, mutators, or getters and setters, which are public methods within that class that allow such functionality. And that is encapsulation. Very easy, very simple. And next we're going to move on to interfaces and polymorphism. Okay, so now we're going to go over interfaces and polymorphism. So, I created an Apple interface class, and in Java we can do public interface Apple interface to create an interface. And you'll see I have two methods: public string get name and public void set name with an input parameter string name. Now the thing with interface classes is you can define your methods, but you can't implement any functionality within them. Instead, you have these subclasses that implement the actual interface and then add their own unique functionality into them. Such as this public class that I written here, which is Gala, implements Apple interface. We can also put whatever variables we want, and you'll see that I'm actually using the same exact ignore this actually. You you can I'm sorry. You'll notice that I have the same exact definitions for those methods that are from Apple interface with their own functionality in the actual subclass itself. Now, you need to use those exact method names and those exact number of methods in order for it to actually function. So this is just one way to prevent code duplication in a sense. Each of these subclasses will have those exact methods with their own unique implementation. So if we go over here, we will call Apple interface Gala is equal to new Gala. Notice how we haven't done new Apple interface. That would effectively do nothing. We have a type of Apple interface, and within that type we're instantiating a new Gala reference. And then we have Gala.setName, and we S out the name of the actual Apple itself. As you can see here, Apple interface new Gala. Now if I go ahead, copy this and just do Gala clone, for example, this can also implement the interface, but let's do something a little different. We'll do set name S out name set. Go over here, so that has its different functionalities. So we do Apple interface Gala's clone is equal to new Gala clone, and we could do Gala C dot set name to Gala clone Apple, for example, and then we could do S out for the Gala C as we can see here. The Gala clone has the same exact methods that are defined within our interface, but having similar but more functionality, or more functionality in the method of set name itself. Now I have Gala and I have Gala clone. As we can see here, these are both types of Apple interface, Gala, and of the new instance of Gala and Gala clone. This right here is polymorphism. What is polymorphism in OOP? Polymorphism are objects that take on many different forms. This describes different classes, many different classes that implement an interface, a single interface, such as Apple interface, and Gala clone, and many other classes can implement this interface. Now you can go ahead, and let me write an example real quick. Classes that implement interfaces can implement many different interfaces. Now I haven't actually done this before. I'm pretty sure the syntax is like this. Correct. Though it should be giving me error, but Apple interface, we'll just get rid of these. We have a new method called public string, and it's usually I think it would have gave me an error, but I guess we can just do public string to string, and we'll do S out the Apple name plus name, and this I'm sorry, that I don't know what, I'm being a rookie right now. Return, I don't know why I do S out. There we go. And this does not exist in Apple interface. This actually exists in Apple Interface 1, as we can see. So we'll go over back to main. We'll go ahead and do gala.toString, and you'll see that that works perfectly fine. So classes can implement multiple interfaces, but as we see on the next topic, which is abstract classes or superclasses and subclasses, you'll see that while you can implement many interfaces in one subclass, you can only extend one abstract class for a subclass, and we'll go into that more in depth in the next segment. So that is interfaces and polymorphism at play. Again, in object-oriented programming, polymorphism are object references that take on many different forms. They are classes that implement a single or multiple interfaces. Many classes implementing said interfaces. So the next and final topics for the main basic concepts of object-oriented programming is abstract classes or superclasses. So the final topic is abstract classes and inheritance. So we have Apple Super over here. Where is Apple Super? I closed it. Let's get rid of the interface stuff that we did in the previous segment. And here we have public class Apple Super. Now you'll notice this time instead of interface, it's an actual class, and we have defined some functionalities such as the default constructor itself, which is just going to set the name of the apple when you instantiate the actual object reference itself, and then of course a getter and setter. And we have Red Delicious over here that actually let's do Granny Smith. As you see, we have Granny Smith over here that has its string itself, which is the same thing in the superclass itself, and we have our constructor for Granny Smith. Now instead of doing this dot name is equal to name, you're going to get an error. This is where the super call comes into play, and you just do super and put that in parentheses, and you can go ahead and set the name within the Granny Smith instance itself. Let's get rid of this, and we could technically use polymorphism for this. I guess we can do it for this example. We can do Apple Super GS is equal to new Granny Smith. GS Apple, for example, and that'll work just fine. GS dot get name. Now here is where the abstraction and inheritance comes in. You see we have no method of get name because it's getting it from our abstract class or our superclass right here, which is get name. So this is, unlike interfaces, it's a more extensive way to prevent code duplication. We have our abstract or superclass here that has the basic functionalities for all the subclasses we want to extend it in. So we have a abstract class called person, for example, and each person can be like the person can be like our subclasses. We can have parent, child, grandparents, etc. But that person is the foundation of all those other people. That's probably more the real world example I would kind of give. Or in this case, we're doing apples. We have an apple, the default apple, and we have many different types of apples such as Gala, Pink Lady, Red Delicious, Granny Smith, etc. This is just to prevent code duplication, and to pretty much have a more cleaner code. And this is one of the most important concepts of object-oriented programming is abstract classes and inheritance. This is one of the most important things in OOP, and it prevents code duplication and pretty much promotes clean and efficient code. Now, as you can see, I did use polymorphism here in a sense, but this doesn't work all the time when it comes to abstract classes. So we're going to do Red Delicious here. And when you have subclasses that extend upon or use your abstract or superclass, you can not only just leave out the methods that already exist in your superclass, you can also add more methods, more functionality, such as this setNameInput method. However, if we try to call it here in type of Apple Super and instantiating a Red Delicious object reference type, we cannot call the method of setNameInput because the actual type of this instance is Apple Super, which is our superclass, and not Red Delicious that has that additional functionality. So I wouldn't recommend using polymorphism when you're doing inheritance with abstract classes and subclasses. So just do Red Delicious. And as you can see here, we don't have our getter and setter that is in our superclass or our abstract class, and we can use those methods and their functionality just fine. As demonstrated here. So how about we use that additional functionality that we said we were going to use that is not in our superclass that we have Red Delicious extended upon, and but actually in our subclass itself, which is setNameInput. So rd.setNameInput work will just fine. This is just a method that will which will implement scanner and take in a name via keyboard, just like this, and we'll do Red Delicious Apple Amazing or whatever. And as you see, it has changed it, the name of our apple in our Red Delicious instance to Red Delicious Apple Amazing. However, there's something we should notice here. If you're trying to modify instance variables that were original to the superclass or the abstract class, you have to put super. First off, it's always best practice to have accessors and mutators or getters and setters, especially since this is private. Of course, we want to promote encapsulation. You can't just do name is equal to new name, because then this is not going to work because of the extension with the superclass. So if I try doing this to like test, it's not going to work. So you always want to go ahead and do super, use the super call, and you access the method from the abstract class you're extended upon, which is Apple Super. Use set name and then new name. Very intuitive, and it will work just fine. And of course, if there is a constructor already in your superclass or your abstract class, in order to actually set the instance variables that were originally in there, you have to use super I think I already went over this, and then, oh, whoops. You just have to use super and encapsulate, not encapsulate, and use parentheses and put name within it. Of course, you can have other variables in here that are unique to the subclass itself. Name2 is equal to name. And you can do public string get name2, and then return name2. That's out name2. I'm sorry, rd.get name2. We'll comment these out. And we'll get it just like that. Just to verify that, we'll just put it with test, just like that. Which that instance variable itself is unique to the subclass. So that is inheritance and abstract classes. A more extensive and important way to prevent code duplication. Instead of having many classes that have very similar or exact functionality, we can have an abstract class or a superclass that implements, not just defines like an interface, but actually define and implement those basic methods and their functionality, then have a subclass to extend upon the abstract or superclass, and if necessary, add additional functionality without having to define and implement it again in that subclass. Now, of course, I have Apple Super here because of the way abstract or superclasses work. You can't just expand upon. You can't implement multiple superclasses. That's just not possible. But with interfaces, you can implement many different interfaces, as we saw in our. Or was it over here in Gala clone? Yeah, in Gala. You can implement many different interfaces, but for abstract or superclasses, you cannot extend upon multiple superclasses. So I hear there's a very common interview question among my colleagues at school about abstract versus interfaces. Abstract class, which is the superclass, which is what we just went over, key part of inheritance, allows you to create functionality for subclasses, not just define it, but implement the defined functionality for subclasses that can either be implemented or overridden or extended upon, and even add additional functionality that this abstract class does not have. So one thing I forgot to actually go over, and we can just do that in our Red Delicious example, is we can do, we'll just do, where's Apple Super? See how we have a method called get name? We can actually override that in our subclass and add additional functionality. This is an overridden version of getName in our subclass. And we can do getName here. And we have some errors. I think that's in Gala clone though. Hopefully it's not detecting that. Yeah, it doesn't detect that. And as you can see, this is an overridden version of getName in our subclass. So we can go ahead and override existing functionality that we're extending upon our abstract class and add or override its functionality. Now the reason why we got the null there in the bottom, do same thing as our additional or our brand new method here do super.getName. Again, accessors and mutators, getters, and setters are very important to pretty much every class you develop. So again, back to the whole interview question. In abstract versus interface, abstract classes allow you to define and implement functionality that subclasses can either implement, or so you don't have to write it again, preventing code duplication, or actually override it, having those subclasses unique functionality or additional functionality. You can also add additional functionality, define more methods, and implement more methods that the superclass or the abstract class doesn't even have in that specific subclass. While interface allows you to define your functionality but not actually implement it. Not actually implement it, just define it. And the last part, very important part, is subclasses can extend upon only one abstract or superclass, whereas any class implementing interfaces can implement multiple interfaces. And that is pretty much the gist between abstract versus interface. Again, abstract create functionality for subclasses, got to either implement it or override it, or even you can both define and implement it. And you can also add additional functionality within that, add additional methods and the functionality within that specific subclass. Interface, you can only define the functionality but can't implement it until you implement it within your subclass. Classes can implement multiple interfaces, but subclasses can only extend upon one abstract or superclass. And that is that is inheritance and abstract or superclasses. So, in summary, we went over primitives versus references, object references. We went over encapsulation. We went over polymorphism and interfaces, and we went over abstraction or abstract classes, superclasses, and inheritance. These are the fundamental concepts of object-oriented programming, and I covered the basics of them, and I hope this video helped you guys out. Again, I take pride and passion in learning from other developers, so if I explained anything in this video improperly, or I just need to explain a bit better, or I need to expand upon my explanation, please leave a comment down below and I'll make a future video addressing it. Again, I love learning from you guys, from other developers. So I hope that helped you guys out with this basic OOP or object-oriented programming concepts video. Thank you guys for watching. I do appreciate the feedback again, so leave a comment down below if there's any feedback you would like to give. And that's about it. This has been Slink, developer of Slinksoft, and have a nice day. See ya.